So in this video, what we're going to talk about is the first derivative test, which is section 2.1. And basically what we're going to do is we're going to look for ways to find what are called the relative extrema of functions. So let's say that we have some function that looks like this, which we'll call f of x. Then the relative extrema are the y values of f of x that are bigger than all the y values in some neighborhood around them. So for instance, right here, we have two places where the y values are bigger than all of the y values around them. So these here we're going to call relative maxima. And when we're asked for the relative maxima, what we're looking for is the y values that are associated with these two peaks right here. And then we also have in this picture what's called a relative minima, because this y value is smaller than all of the y values around it. So we'll call this a relative minimum. And one thing to notice is just because it's not the smallest value everywhere on the graph, that still allows it to be a relative minimum as long as it's smaller than all the y values around it. Okay? We're also going to talk about in section 2.4 what are called absolute maxima and absolute minima. And the absolute maximum is going to be the place where the graph takes on its biggest value everywhere, which you can see in this case is going to be this peak right here. So this is the absolute maximum. And the absolute minimum is going to be the smallest value of f of x anywhere. But in this case, since f of x goes down forever in both directions, we're going to say that we have no absolute minimum. So we have no absolute minimum. Okay, so what we want to do is we want to find a way to figure out where these are. And if you notice on this graph, the relative maxima and minima are happening at places where the tangent line is horizontal. So if I drew a tangent line here, and a tangent line here, then in those places f prime of x is equal to 0. So to find the relative maxima and minima, which we call the relative extrema, we want to find the x values where f prime of x equals 0, or f prime of x is undefined. Okay? And so we could also look at a graph something like this, like the absolute value function. And if we did something like that, we would have a graph that looks like this. And in this case, if you remember, we have a sharp corner. So that's not differentiable there, but our relative minimum is going to be at a place where f prime of x is undefined. Okay, so our first step is going to be to figure out where f prime of x is 0 or f prime of x is undefined. And then what we need to do is we need to check the sign of the first derivative on both sides. So in a case like this over here, my graph is going down, so f prime of x is negative. And over here my graph is going up, so f prime of x is positive. And so since f prime of x is changing signs, that means that we're at a relative extrema. In this case, we're going from negative to positive, so that tells us that we're at a relative minimum. We could also have cases where f prime of x is equal to 0, like something like this. So we could have a graph that looks like this. And at this particular place, f prime of x equals 0 because the graph has become horizontal. But here what we have is to the left of this point, the graph is going up, so f prime of x is positive. And over here the graph is also going up, so f prime of x is positive. So since the sign of f prime of x doesn't change at this particular value where f prime of x equals 0, we have no relative maxima or minima there. So what the first derivative test does is it checks for the places where f prime of x equals 0 or f prime of x is undefined, and then we check the sign of the first derivative on both sides and see if it changes signs. And if it does, we report the y value of that particular place on the graph, and that's going to be what we call our relative maxima and relative minima. So let's look at an example of this. Okay, so let's say what we want to do is we have an f of x which is equal to 4x cubed minus 9x squared minus 30x plus 25, and we want to find any relative extrema. So the first thing we're going to do is we're going to find the x values where f prime of x equals 0 or is undefined. All right, and these x values here have a special name. They're what are called the critical values. Okay, so if I find f prime of x by using the power rule on f of x, that's going to give me 12x squared minus 18x minus 30. And if you remember from way back when, this is a polynomial, and a polynomial is always defined. So all I need to do is figure out where this is equal to 0. So I'm going to set this equal to 0. Okay, and then what I'm going to do is I'm going to try to factor this and solve this like a quadratic equation. So the first thing that I can do is I can factor out a 6 from each of these terms. So I have 6 times 2x squared minus 3x minus 5, and that equals 0. And then if I divide both sides by 6, I get 2x squared minus 3x minus 5 equals 0. And then I'm going to use that technique that we did previously called the AC method to factor this. This is a good chance for you to start practicing your factoring of quadratics. And in this case, what we get is we get x plus 1 times 2x minus 5 is equal to 0. So if you remember, this can only happen when x plus 1 equals 0 or 2x minus 5 equals 0. So this is when x equals negative 1 or 2x equals 5, which says that x is equal to 5 halves. So these two things here are what we call the critical values. So this is one, and this is another. These are the critical values. Okay, so the next thing we want to do is we want to figure out what the sign is of f prime of x on either side of the critical values. So this is what I'm going to do, is I'm going to draw a number line. So this is step 2, is check sign of f prime of x on both sides of the critical values. The way we usually do this is we draw a number line. So it looks something like this. And then I label these 2 points. So I label x is negative 1 and I label 5 halves. Okay, so up here what I'm going to do is I'm going to check the sign of f prime of x. And there's different ways that we can do this. The first way I'm going to show you to do this is by looking at our factors. So I have x plus 1 is one of my factors, and 2x minus 5 is my other factor of f prime of x. And I'm going to check the sign in each of these regions of the number line. So when I'm to the left of negative 1, so I'm over here, let's say I pick a number like x equals negative 2 and plug it into these factors. So if I plug negative 2 into x plus 1, this gives me a negative. If I plug negative 2 into 2x minus 5, that's negative 9, which is also a negative. And if I multiply a negative by a negative, which is what f prime of x is, it's these two factors multiplied by each other, this is going to tell me that I have a positive up here. Okay? Next thing I'll do is I'll check this region of the number line, so I'll pick a value like 0, and I plug that into x plus 1, and that gives me a positive. And I plug that into 2x minus 5, and that's 0 minus 5, which is a negative. And then again, f prime of x is multiplying these two things together, so it's a positive times a negative, so this is a negative. And then to the right of 5 halves, let's say I pick x equals 3, and I plug it into x plus 1, that gives me 4, so that's a positive. If I plug in 3 to 2x minus 5, that's 6 minus 5, which is positive 1, which is a positive. And then if I multiply those together, a positive times a positive gives me a positive. So what we can see is that each of these critical values, the sign of f prime of x is changing. So to the left of -1, if f prime of x is positive, that means our graph is going up. And if to the right of -1, our graph is decreasing, then that means it's going down because f prime of x is negative. So I can say that I have a relative max at x equals -1. Okay, and then at x equals 5 halves, to the left we can see that our graph is decreasing because f prime of x is negative. And to the right it's increasing, so it's going like this. So if we're going down and then we're going back up at a critical value, I can say that I have a relative min at x equals 5 halves. Okay, so now the final step is to figure out what the y value is at each of these critical values. So I'm going to find f of x at the critical values, and in particular at the critical values that are associated with relative maxima and minima. Okay, so the first thing I'll do is rewrite my f of x, and my f of x is 4x cubed minus 9x squared minus 30x plus 25. And so my relative max is at f of -1. So if I plug that into f of x, if I plug x equals -1 into f of x, what I end up getting is that this is equal to 42. So this here is my relative max. And then if I want to find my relative min, I'm going to plug 5 halves into f of x. And if I do that, I end up getting -175 over 4, which you can do in your calculator. And so this here is my relative min. Okay, so this is basically the procedure every time, is we're going to find our critical values where f prime of x equals 0 or f prime of x is undefined. We're going to draw a number line and identify those critical values and check values to the left and right of the critical values for f prime of x and see if f prime of x changes signs. And if it goes from positive to negative, that means we're going up and then down. So that means we have a relative max. And if we're going negative then positive, that means we're going down and then up. So we're at a relative min. And then our final step is going to be to take those critical values that correspond to relative maxes and mins, plug them into our original function, and be careful you plug into the original f of x, and that's going to give us the y values associated with those relative maxes and mins, which is what we define as a relative max and min.